Hello everyone, am I audible? Okay, okay, fine. I can, yes, I can see that. So, thank you everyone. Now we on the day 3. Day 1, we learned about what the fundamentals of Python programming. We study the Numpy, which is the numerical Python. So we know that machine learning, data science is all about mathematics. It's all about crunching the numbers. So Numpy plays very important role working with the numbers. Then yesterday we discussed about the pandas. With pandas is specifically designed to work with the data frame, or you can say we design uh, pandas library for working with the data science and machine learning also, which is created on NumPy. So then we discuss about the matplotlib, where we design some different visualizations are done. We discuss about the EDA, export data analysis, some cleaning part of it. So data cleaning is done. Now we started with understanding of basics of it. Now it's time to apply or understand the machine learning. So day 3 is all about understanding what is machine learning. So little bit theory and then we go for coding part. So today theory plus coding is a good combination of learning is there. Right? Let's start. So let's understand what is machine learning. Machine learning is the study of algorithms. Machine learning is a study of the algorithm that improves their performance at some tasks with the experience gained from the past. So what we are going to do in machine learning? We are providing a data to the machine. Machine learns on its own on that data, and based on that data it creates its own understanding on that, and which use for applying. For example, if I teach alphabets to the child learns those alphabets and then started using them. Okay, speech humans understand learn it from their parents and the surrounding. Similarly, alphabets we teach. So you can say child learn on its own by observing it, by listening it. That is a self-learning. When we teach that alphabets, so that is a supervised learning. I will come to the types of learning also after this. What is a supervised, unsupervised, and what is reinforcement learning? So machine learning is the study of algorithm which improves the performance of a some task. That task can be anything. So learning is used when for why this learning is important. Maybe we have to create some satellites or maybe some robots which wants to navigate, which wants to navigate. Uh, okay. Now, so audio is a little bit clear. I can see the your voice quality. Can you come to the better network? You are net, then it will be more better because I'm a good network. So, human expertise does not exist on navigating the Mars, so we cannot navigate on the Mars because humans have not landed on the Mars. But we want to navigate there. What comes to the picture? Machine learning plays very important role to perform that, right? So humans are unable to explain their expertise. So humans can, so we call it the speech recognition. So speech recognition is a very important one. Solution to change in time. Routing on computer network. So maybe we have a network which whenever we send email to one person to another person or other through email. So data is hopping from different network. That packets, when the emails are sent out, that packet may go to the different location, maybe far location. But in today's time, some AI-based or smart routers are there, which ensures the navigation of packets. Solution needs to be adapted for particular cases. User biometric. Yes, we might have seen in some offices people have fingerprints or iris scanning for their attendance purpose. So this solution uses in backend as a biometrics, or you can say machine learning, deep learning algorithms are used. So there are many use cases are there. You might have seen some applications on Instagram, some applications on Facebook. There are some apps are there which uses a machine learning. You might have seen some recommendation on some shopping website, maybe say on Amazon, Mintra, or any other websites. Machine learning is hard. Yes, machine learning is quite hard when it comes to writing a complex application. For basic application, it's very easy. So you can see this is the how we look at the images and how machine learning look at the images, because everything, any image or videos, specifically image I'm talking about currently, right? I will not go to videos. Images are stored in a computer in the format of matrix. This is the matrix for computer, right? When it comes talking about the videos are nothing but a sequence of different images. That's what we call as a moving pictures experts group, PEG full form. JPG images are the joint pictures experts group. So images are arranged in successive manners. We call as a video. Right? So images are stored in a computer in a matrix format, and we actually work with those matrix. This is what you look at it. This is how you look at algorithm setting. So traditional programming versus machine learning. Traditional programming complexity is there in algorithm, but ML complexity is there in data. So very complex data, and here we have data, program, computer, and output is the traditional programming. Again, data is there, but data is very simplest form. Program is very much complex. Algorithm will be there. Some complex mathematical approach is there, and then we have computer processes, and we get output of that. But at look at this, we are giving data and program as an input. We have some output at the output of it. Yes, at output we are getting output. Means this is the data and program which tells us this is the output we are telling. So this is input and output supposed to be this. It's a very traditional way of every programming. We use this approach. But in case of machine learning, data and input we are giving input. Yes, data what we are telling computer this is the output we want. Based on that, we are getting a program as output. Yes, machine learning have a different approach. In both the cases, data is input, but here program is the input and output is output. Here output is the input, but program is the output for us, right? This is something we need to understand. What is the difference between traditional programming and machine learning programming, right? Let me move. Where ML is used? Let me move this just a minute. Okay. So where is ML is used? Anomaly detection. There are certain cases anomalies are there. Usual patterns, the telemetry from physical and virtual plants, like a lot of data centers are there. This anomalies usually sometimes maybe for someone is trying to hack into the system. So that is maybe anomaly, and maybe some sort of attack is there, right? So unusual sequence of credit card transactions. Someone is using credit card transactions, and that is at peak of it. Immediately it gets catched, and that catching is nothing but an anomaly detection. Usually it does not follow the pattern, and but it works on some other pattern, right? So this is known as the anomaly detection. Anomaly means does not follow certain pattern. Suddenly some spike is there. Okay. So pattern recognitions. There's another prominent area which works on the pattern recognition. That is the facial identities. Okay, I will check my mic.
Is it clear? Is it clear now? Can I get a response in yes in the chat box or no? Yes. Okay. So another application is a pattern recognition. Thank you so much everyone for responding yes. So anomaly detections. Anomaly detection is discussed now. Pattern recognitions, facial identities of a facial expression. Facial recognition is very important, and it's because based on the facial expressions we can identify the whether the person is in what type of mood. So based on that we can suggest, recommend some music. Music recommendation can be done. Based on that we can recommend the certain type of suggestions for identifying. Maybe we can detect the any anomaly, like say someone is trying to steal something, so we can easily understand from that. Handwritten, spoken words, example is Siri, or the you can say Alexa, or handwritten, because sometimes we don't do the script and that needs to be recognized, specifically when I'm talking about doctors in writing, and we that needs to be read by some system instead of medico. So medical outcome analysis, there are many various, because you might have heard about lot of different medicines are suggested by machine learning, and proper analysis is done, and it is proven that a better analysis is done by the machine learning than the doctor. Okay, but it is unavoidable. We cannot avoid doctors. Doctors are again required. Sensors data and IoT. IoT is nothing but Internet of Things. We can use this and we can suggest when to provide the water, what nutrients are required for particular soil analysis when you perform. So these all are behind that machine learning is working. Speech recognition, NLP. NLP is best example is Chat GPT or Llama. These all models are example of NLP. Speech recognition a part of NLP itself. NLP works on the textual data as well as the audio data itself. Computational biology, where people are working to work on what different DNAs are there, how DNA is coming, how it is connected, and what different diseases possible genetically. So there are a lot of studies are done in the direction of the biological computations itself. So pattern, now not pattern recognition, we can generate some pattern also. Pattern generation, you can say the generating images or motion generating images, example of GAN, generative adversarial network. You might have seen the generative AI type of images on internet. So behind the scene, the ML is the one which is playing the important role. So also it is known as a generative adversarial network, GAN networks. So okay, this is beyond discussion of today, but just I'm giving an example of it. Then real-time analytics is for maybe working on some stock market, or maybe rainfall predictions, or maybe temperature predictions, or so these all predictions are done on real time. So that is another application of it. At the same time we can have predictive analytics. We can predict the near future, maybe what are possible sales will be tomorrow, or maybe in the next quartile what sales will be there, what different products can be sold on internet, or maybe on a physical shop in general, what type of product will be sold tomorrow. Okay, so where ML is used, I just lot of talk about different use cases of it. We use every day. you might have seen some spam images are spam emails are there. Those emails automatically are going to your spam box, like an inbox, outbox. We have spam box, trash. Different boxes are there. So these spam boxes are working with us for very longer period of time. The spam is not today's time, but it is longer time. ML is with us. So one of the basic application we use day to day life is a spam. So detection of spam. This is the very broad view of the machine learning types. You can say that is a broad categories of it. Broadly, machine learning is divided into four different types of it. It is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning, when I'm saying it's a learning, uh, we have a data set available with its labels. So if data set is labeled, then we can call it as a supervised learning. So maybe we use for continuous data variable, and we use on categorical also. Continuous is, for example, 1.1, 2.1, 3.1. Some numbers are there that are continuous. Categorical, for example, we can say we have images like a dog, cat, um, rat, so maybe some other animals. So but these categories are there. Okay, so those category 1, category 2, category 3, category 4, maybe someone alien, not alien, male, female. These are categories. Maybe it's a binary when we have two categories like a male, female, right? A true or false, day or night, or whether dog or not dog. But there are multiple categories are there: cat, dog, rat, right? Peacock or parrot. So these are categorical target values are there. And when you want to classify into multiple categories or two categories or binary classification or multi-class classifications. So there is a categorical conversion is there. When I'm talking about continuous target values, we have regression. You might have studied some concept of regression in school days also. When we draw a line like y is equals to mx plus c, or so there's the equation of lines. Like the simple linear regression example, which is used for house price prediction, or maybe any type of prediction where it does not require the classifications. So regression is the example of continuous type of target value, an example of supervised learning. Then the second category is about unsupervised learning, where we have target variable not available. In a first case, we know that what target we want. We want certain target. I said I want to classify our data into two categories, whether the given image is a dog or not dog. Okay, binary classification I'm doing. So I am just telling this is what I want, and this is what the labels are given in the image. Okay, for each image there is a label is provided. It's a dog image, it's a cat image, this is not dog image, this is not dog image, this is a cat image, this is a rat image for multi classes. This target variables are provided, values are provided. That's why we call it as a supervised learning. Now when I'm talking about the unsupervised learning, in unsupervised learning we have target variable. So we don't have target variable available. There's a one question: how ML will help in data science? Can you explain with the example? Yes, that's what I'm talking about. ML is you see in data science. ML algorithms are used to work on this data science. For example, you have a data of last 1 year data of say rainfall. Okay, Mohammed, listen carefully. You have a data of rainfall for 1 year, right? Or a 10, 20 years. This data set. Now you will perform some analysis on that. So when you are working on data science, you talk about four different analytics. Okay, just as you asked, so I'm diverting a little bit based on what today discussion. So we perform four different analytics on that data science. One is prescriptive. We talked about what happened, descriptive analytics on that data science. What happened by looking at that data? What happened? Then we talked about the descriptive what happened. Then we talked about how it happened. We diagnostic it. We diagnostic it. So how it happened. Okay. And based on that, so we talked about the predictive. We can predict what will happen. Okay. So we talked about the predictive what will happen. So then that is a predictive analytics. So looking at that data, we predict. So that predicting that value, we require some machine learning algorithm, because we want to suggest something, we want to recommend something. Data science uses machine learning, data mining, or big data algorithms to come up with those recommendation or the future requesting. And then the fourth analytics we perform is recommendation, right? Prescriptive. It's just like when you visit a doctor, you have some clinical problems are there for you describe them. Descriptive analytics, you perform them. And this is I'm suffering from, I have a temperature, then I have this symptom 1, symptom 2, symptom 3. Doctor look at it, it diagnoses it, okay, and then it tells how it happened, right? And then based on that, doctor prescribe you some medicine. If you don't take this medicine, you will suffer another issues. Okay, there's a predicting it. Maybe you will have a higher temperature, you might be you need will have to take some, you need to hospitalized, so it will become chronic if you don't take medicine. So that is a prediction. And then prescribe you some medicine, you have to take like this subodh doper sham, like that. Okay, so it is a prescription is provided. So this is a four stages in this data science is working. But to predict that, to prescribe that recommendation, we use machine learning algorithm, right? I think it's understood by everyone. I assume that I can get some yes or no on the chat box. Please everyone provide. Okay, I get what says. Yes, yes, yes are coming. So machine learning types, the third type is semi-supervised. Now we have some variables which are having some target variables are set out, and some target variables are not there. So means initially form some data sets, some part of we are dividing the data into two parts, where we have target variable and we don't have target variable. So when we do not, and then we togetherly we work on that. So we can have the classification, clustering both. If you look at the second here, we have a clustering and we have association. That is a market basket analysis. A priori algorithm is of that. Clustering, we have k-means algorithm. Customer segmentation, when you want to segment in different customer, different categories of that, we don't have labels available because we cannot tag any customer. Maybe some customers are prone to buy certain type of products and all, some customer on some other type of products. So we have to group them together. Okay, it usually happens based on the region, based on their authenticity, based on their different criterias are there. But those criterias are not known to us. Though that when it is not known to us because target variables are not available, we cluster them, we group them by unsupervised learning algorithm. There are many algorithms in unsupervised. There's a QR algorithm, K means clustering, K mean K medioid hierarchical. Many algorithms are there. In association, we have a priori, and then FP growth, or maybe you can say Park Chain U algorithm, PCY. Semi-supervised classification clustering, we can mix the technologies of the, or you can say the flavor of super and super come together, and we can have semi-supervised. Reinforcement learning, you might have played lot of games in the past. This is something we all have done that. Whenever the enemy is there, an enemy is computer, it's not even an agent. And those agent, like you might have played Counter Strike, or maybe you have played Dota, or you might have played some games like you can say called Clash of Clans, or maybe any other game. So in that games, some opponent or maybe some different animals, some different objects are shown there. Those objects are nothing, and which are playing and interacting are nothing but an agents, and that is where the reinforcement learning is playing important role. This is how it happens. Let I will give an example later on. So let's understand from this. A very good example is provided on this slide. This is the duck. This is a duck. Okay, this is not duck, not duck. And supervised learning. Okay, we get a predictive model, and then we are providing next time this particular type of object, which is quite nearer to this because it has a feathers and all. But these two objects does not have the feathers, right? Then this particular object is predicted as a duck. because we have provided labels here. You can check, we have provided labels here, and these labels are provided. That's why our predictive model is in position to classify as a duck. This is the power of supervised learning. Or where it is supervised, because we are calling, we have the labels present there, and when the labels are present we call as a supervised, and those are known as a classification algorithm. Okay, we can use any classification algorithm here. It can be k nearest neighbor, or you can say we can use the random forest, or maybe if there are many algorithm, or maybe we can the CNN, convolution neural network, maybe ML, and when you can work on deep learning also, right? Then there is another algorithm that is unsupervised learning, clustering algorithm. We have image 1, image 2, image 3, image 4, image 5, but I have not provided any label here. Not a single label is provided here. As I have not provided a single label, this is called as unsupervised, because label is not provided. In the previous case, I am writing it here: duck, duck, not duck, not duck. These labels are provided. That's why it is supervised. When I'm not providing the labels here, it become unsupervised. And because of that, we cannot use classification algorithm. We have to read on this. We have to rely on clustering algorithm. So classification or clustering, both are performing a grouping of the element. Both are performing the groupings, or we are segregating them. But approach is, we have to apply different approach, right? Based on the features, we are categorizing them into different. Now these all are there, and we have clustered into three different parts. This one is going to this one. Second image also going to this one, group cluster one, and fifth image also going to cluster one. But look at this third image is going to second cluster, and fourth image is going to third cluster. Interesting, very much interesting. We have talked about here binary classification: duck, duck, not duck, not duck. But these two objects have a different features, and clustering algorithm is in position to understand those features and categorizing into separately. It means this help us to achieve the grouping them, where initially when we perform classification based on our labels, the model was little skewed, because we told that it is not done. But here it is learning on its own, and based on its features, it categorizing in three different categories are created, or you can say three different clusters are created. Okay. Any doubt so far? Understood everyone? Can I get some responses? Yes, yes, yes. Okay, in the chat box. Okay, there is a one question. Certificate, attendance and certificate. So just a link is provided. You just have to click on that link in the chat box, which is pinned. You can click and you can actually click and open it, and you can give mark your attendance. Okay. So okay, thank you so much for you understood. Sureka, Praveen, and Elite Beast, Praveen. Thank you so much. So now next is a classification regression. Now we understood the difference between classification and clustering, and there is a classification regression. Both are supervised. Now what is the difference between these two? Okay. Now we have this classification. We want to classify this two into apple and this into banana. But when we're talking about the regression, this again the image are taken. Features are written against. Suppose for example, these apples are usually spherical is a one feature. Color is red. That is a two feature number two. But look at the second object. It's a banana. Banana having a some lane. Color is yellow. So these two different features are there. So these based on this feature, we are able to classify them. There's a classification. What's the regression? Regression is something we are able to predict. Now this is the line we are able to draw. If something is linearly classified, right? So you might be have a question, sir. What is a feature, sir? This feature is nothing but let me get an example of it. If I show you some image of any celebrity, only eyes will be shown. We are in position to predict a a आंखें किसकी है, okay? Whose eyes is this? So we are able to understand who this eyes belongs to, right? There was sometimes on television, or maybe in the past, or in the KBC, it is shown that they are showing just small portion of the some celebrities, and they are able to predict. Or maybe we just hum the song, this humming of the song, and we are able to predict the whole song. Maybe similar hummings is for multiple song, but we are able to, because of the certain features of each song is different. So features are very prominent for that. Specifically, if I want to segregate between the apple and banana, my features will be like color. Very easily I can do, right? Or maybe the length, or maybe sphere, or one or two features are sufficient enough. I don't require that some features which are common of them. If I want to classify them, categorize them, I require only distinct features. I require only distinct feature. The same features are there. I cannot distinguish between the two objects. So to distinguish between two objects, I should get those prominent and distinctive features. For example, I have this apple and this banana. I talked about the distinctive feature, but there are some features which are very common. Both are fruit. Okay, it's a very fruit. I know this feature is very common for them. I said both are sweet in nature. Yes, both are sweet in nature. The common feature, I don't need it. So features which are distinctive are essential. And after that only we can classify them. This is just an example. There are various methods where which we can use for identifying those features. Many algorithms are there, right? So there's one question. Let me take that question. Between unsupervised and supervised, how to know what kind of algorithm to opt for when dealing with the different types of data sets? Very good question. Appreciated. Lejon Khanse. So thank you so much. Very good question. I highly appreciate. So thumbs up to for that your question. Yes. Unsupervised and supervised. Which kind of algorithm to be used? See, let me tell you an example. There is no fixed rule. There is no fixed rule. There is no left hand rule, right hand rule. If there exists a left hand rule and right hand rule, we don't need engineer to work on data science. We have to try different algorithms. Maybe with experience only you can understand. Okay, this type of data, I can try this algorithm. Yes. Even data scientists are not confident enough ki, okay, this data set here, this algorithm definitely will work. They can vouch, okay, I feel that 90% this algorithm will work. Yeah, this will work 90%. Because that data scientist, data engineer have that experience over the past. But there is no fixed rule. We have to try. I will try algorithm 1, algorithm 2, algorithm 3, algorithm 4. For example, I may be working on, say, predicting the certain cells. I will try algorithm 1, I will try algorithm 2, I will try linear regression, I will try logistic regression, I will try maybe multilinear regression, I will try LSTM, long term, short term memory. So various algorithms are there. I will try RNN. So there is no fixed rule. I have to try, and looking at those results, and then I can say, okay, this is the algorithm, it will work. As soon as time passes, time lapse is there, we have to try some other algorithm. Sometimes it doesn't work. So this is a very progressive steps. When you are working as a data scientist, you have to regularly check new algorithms which are coming into the market, because now if you looked at any new algorithms are coming, over the 10 years, we can see the rapid growth in the technology side of it, and many algorithms are coming up. Many algorithms, and there's a different versions of the same algorithms comes. That tweak is done by data scientists. For example, someone wants to do some research, they do research and they come up with certain parameters. If it is a tune, then that parameter tuning is done and they get a better results. So, answer to your question, there is we cannot decide the algorithm immediately. We require to look. We have to explore the data set. We have to from EDA, explore data analysis, looking at data and our past experiences as a data scientist over the period. Then we can try an algorithm. Now there will be question, sir. We are very new, sir. How should we understand? Very simple. You have to try and understand, or you have to connect with the experienced person who will tell you. Or another solution, if you cannot connect, you cannot try all algorithm, you have less time, go to the literature, read the research paper. They talks about which algorithm is work on certain type of data. People are writing lot of articles, journal, papers, conferences where you can read. Uh, Not a nerd has asked the question, uh, won't algorithm be different for every type of ML, like restricted learning, unrestricted learning will be algorithm for both be the same or not? Yes, algorithms are different. Classification algorithms are very different. When you have a data set which are not labeled, we go for clustering. If it is a label, we go for classification. Or we have some data label, some not label, we may go for semi-supervised learning also. In today's time, we have self-supervised also. Okay, and we can try those algorithm. But yes, there are various categories are there. We have to look at the what problem statement, and again I'm repeating, we have to check our data set, what type of data set we have. This is we have to apply deductive approach, uh, which will be we use one algorithm, we use another algorithm. Bhuvneshwar Reddy is asking question. Sir, can you please explain what is statistical analysis and how it is related to data science and number algorithm, sir? Um, Statistical analysis is analysis. Let me give a simple example. Descriptive analytics. I have some data set, and on the data set, I will be checking say mean, median, mode. Okay, I have some numerical data or categorical data. I will check mean, median, mode on that data set. Okay, so that is statistical analysis. I will basic statistical analysis I'm talking about. So that algorithm, so that statistical analysis help me to understand what is it tells me what is my data, the what kind of uh, pre-processing I have to perform, and once I perform the pre-processing on that, I am able to apply my machine learning algorithm. The statistical analysis at the base of it help me to understand where where my data set stands. What is the category of my data set? Or use the word quality of my data set. We cannot use the degraded quality of data set. We want a quality of data set. Okay. There is a question. Can you bit explain on a self restricted model? Okay, I will take. I will reply to this. You can take my email ID and I will reply to this audio email, because I'm going to next copy, because we have less time. The next thanks, but I think the algorithm work based depending on the criteria, certain data set. I already told you it's work on a certain data set. We have to check our data set. I heard NLP work based almost on every data set. No, no. NLP, how NLP work on image data set? No, it will not work. NLP work on textual data set. Okay. Work based almost on every data set, but some for them to work X inputs have to be converted. Am I am oh, okay. Am I right or I am right? I don't know. You are written. To work on X inputs have to be. Yes. NLP no work on textual data set we require to have perform in different stage pre processing of it. maybe tokenization, or maybe you have to apply some limitization and all, and then you have to try different approaches of the POS tagging and NER and all. Then yes, you can try all of it, but image data set it will not work. Then you cannot fix NLP is going to work on all models. No, you have the numerical data. How will you work? NLP model is going to work on that. It will not work. Images, NLP not going to work. Different data set, different algorithm. It's just like our mother cooks lot of dishes, and every dish has its own processing power. All recipe doesn't work. Every dish has a different way of working style, right? So next, attendance link no work. Please IT team look into it. Check the attendance link. I read that deep learning is the first step that builds ML models, and ML models make up AI. Can you explain it? I read the deep learning model. Learning is the first step to build ML models. Not necessarily deep learning. ML, what today I am discussing about a textual data set, that does not require to use a deep learning. ML is a larger set. If I draw a Venn diagram, this is the machine learning. In that, this is the deep learning. This is our deep learning. Okay, this is machine learning, and the whole larger set is our AI. Okay, so not necessarily it is same. Add it. Okay, thank you, sir. Well, thank you. Okay, I'm just as I there is no question in the chat box. I'm just moving ahead. So unsupervised learning, yes, good dog, bad dog. We are looking at the features and then we are deciding it. I will talk about supervised and unsupervised. Okay, these are some definitions which are again already have discussed. What is a regression problem? Try to fit a mathematical function that describe a curve. Say regression. I'm coming to this. Okay, for example, it's a regression is like a mathematical problem. So what is a regression? What happens? What we do in regression. For example, you have a data set for a say last on speed and distance. Okay, very typical data set is there, speed and distance, and I have a distance cover and speed. Okay, this data set for over almost 100 observations are with me, and I can find relation between speed and distance. Though there is a through physics, we have formula, we can get it, but to data set the regression problem we can calculate. We can calculate with the allow regression also. So regression helping us to draw the curve where the relation is there. Because this is, for example, I will I will use this particular image. I have this image. I have speed here and I have distance here. I have different points are here like this. And if I draw a line like this, I can actually get what the next point will be there with the help of regression. So regression is a try to fit a mathematical function. So there will be, you might have a question, sir, how this model in machine learning model, how this model looks like. Models is not rocket science. For the regression, it is look like equation. Y is equals to mx plus c. For a decision tree or random forest is like a tree type of, is a tree. Okay. So every algorithm, computer stores machine learning model differently. Maybe for a CNN, RNN, or deep learning, it stores in the format of weightages, neural network, and all. So it which so it depends what algorithm is you are storing using it. Each algorithm has output in different formats, so it has a model in different format. So understand that. Any doubt so far? Can I get yes in the chat box, everyone? I will see the watcher. Okay. Thank you. Lot of S. I can see Sureka Chavan. Can you explain it again? It's a YouTube live. You can just little go back and you can re-listen it. But I will just move forward. Uh, Linear regression and gradient descent. Yes, these are very typical example of linear regressions, and the gradient descent is an algorithm which helps to find out the optimized solutions. Okay, the use for optimization. Okay, but not today's discussion point. I will be discussing in some other live when you were going for deep learning and um, type of solutions. But gradient descent is very popular algorithm for optimization. Classification, you can read it. The taking input vector, deciding which n classes are there. I already talked about this. How we can classify multiple classes are there. I discussed about unsupervised. So regression classification is example of supervised, and the unsupervised is a clustering. There are various clusterings are there. I talked about k-mean, k-median, hierarchical, then Q algorithm, and the reinforcement learning. These are agents are played. I talked about the agents are there, and learner takes a policy. Uh, Reinforcement learning application, game playing, robot in maze, and the multiple agents and partially observability. Now, let me know game playing. When you play a game, you are against some. Suppose you are playing as a counter city, and there are terrorists. The terrorists actually moving around the arena. So that arena, that agents are learning on its own. Okay, it does not uh, cross the border through the walls and all. Okay. Yes, you will get a slides also. Please note my name attendance. Okay. Okay. There is no other question. Game playing, robot in a maze. For example, you might have heard about Japanese is quite ahead in case of the robots and all. There are shops, in that shops the robots are delivering the coffees, so or maybe any other product. So those, suppose for example, take an example of coffee shop, of a coffee shop where robots are delivering it. How the robots are trained? Those are trained with the help of reinforcement learning. Okay, and in that case, robots are moving around that arena, or you can say that coffee shop room. If robot delivers the coffee, we we provide the points, and as soon as robot does not it does is, for example, robot touches the coffee table or touches the some chair, so we are penalizing it. So if the robot works properly, we give positive reward. If robot does not work properly, we give negative reward. So positive negative rewards are there. So negative rewards are known as penalty, but in mathematically we call positive and negative rewards. So robot is moving around the coffee room, and robots are learning based on that. So as robot is penalized or rewarded, so or positive negative rewards are given based on that, robot keeps a track of it, and based on that, robot is able to move around, and that is known as reinforcement learning. One of the best example of reinforcement learning, coffee in a coffee room, robot is moving. Multi-agent, for I talk about one robot, you can have multiple robots also. For example, in a I will take same example like maybe you can take the some farm relay, or you can talk about the Clash of Clan or Clash of Royale. Multiple, though you are playing a game, there are multiple agents which are there around you. Those are also working. For example, you are upgrading multiple objects, multiple buildings. So multiple things are upgrading it. As it is upgrading multiple, that's why those are the multiple agents, and they are also communicating among them. The agents can also communicate. Like for example, in a Counter Strike CS, as you are playing against computer and you are as a city, the terrorists among them can communicate and they plant the different bomb in certain arena. There's some, okay. So these are they can communicate. And partially observable. Partially observable, you can say when you are actually not knowing complete arena, you know certain part of arena, still able to perform because of the mathematical reinforcement learning. So there is a different algorithm for that policy. Algorithms are there which is used for partial observability. Like an example I can give, you are able to show certain portion of the image and we are able to understand what second portion of the image is there, because humans eyes are able to reconstruct. Similarly, the reinforcement learning is in position to get into unknown arena also if the unknown arena is not known, right? Okay, so let's move ahead. Yes, thank you for Clash of Clans. Okay, data. We think of data as a vector in a fixed and dimensional space. Look at this data set. We have heart disease rates are provided in first column. Second, cigarettes per day, exercise per day. This is the data. And we have plotted out. Okay. We plot it on the graph. This is a graph we have plot. This is we are looking at data as a vector, fixed dimensional space. And we are plotting heart disease and cigarette, and this is with respect to each of it. Okay, so and third dimensions are shown with the colors. So what is that exactly? So data is treated as a vector, means you can say in a table dimensional way, and we are plotting it, right? Data set example, iris data set, number of training examples. This is one of the popular data set is a iris data set or iris data set, which number of training example 150, number of features 4 are there, sepal length, colors, these different and weight are provided there, petal wells, and the classes Setosa, Vesocule, and Virginica. These are different classes are provided. So this dataset consists of classes, or we call as labels. So we can try classification algorithm on this dataset. This previous data set, we can try regression. But here, that we have some classes are available. As classes are available, we are able to apply the classification algorithm on this. We can try the random forest. We can try the decision tree. We can try the naive based algorithm, which is a probability based algorithm. So algorithms are basically um, decided based on what type of output we want. It may work, it doesn't work. We have to try. Sir, how to know uh, when dependent variable and independent variable question is in, I cannot read, in a large data set. Okay. So for example, y is equals to mx plus c. Okay, when I'm talking y is equals to x plus c, this x is our independent variable, and x is our independent variable, and this y is our dependent variable. Why x is independent? Because x is the one which defines the y. Okay, and how to know dependent variable? That we need to decide. This is a y is why we want to predict the variable which we want to predict, that becomes our dependent variable, and the rest other variables become our dependent and independent variable, because that is other variables are defining this variable. So we will call as them as independent variable, and this is called as a dependent variable, right? For example, I want to predict the rainfall tomorrow. Okay, so how much rain happened on particular day? These are become my dependent, independent variable. And for tomorrow's date, that day, tomorrow's rainfall become my independent variable, right? Tomorrow's date become my dependent variable. Tomorrow's, I will show you how it will be calculated. So training data, we'll have that calculation and coding also. Training data, machine learning algorithm we apply on the training data. We have certain hypotheses is there. Maybe we design two hypotheses, alternate hypothesis and null hypothesis. Hypothesis means our assumptions we have. For example, certain location, say someone claims that I have in last 15 days temperature rises there in certain city. So what we do is we'll take last 50 days a data set of the temperature, um, and we calculate it using regression and all. If it follows, then you can say yes, it is increased, and there's alternate hypothesis, yes, it does not increase. So we it is not a hypothesis. So we have new input, we check on our input and we estimate. Data set. Data set is basically divided into two parts. Data set is divided into two parts: training and testing and training data set. Actually, in practical, if you have large data set, we divided it into three parts: training, testing, and validation. Also, in training, we are training the model very clearly, and in testing, uh, we use the we use the we test our model, and this help us to calculate the accuracy, precision on that, and how much error is there. And validation is a mixture. It was a validate. Let me give a real time example of it, you will better understand. Right now I am teaching you, so that is a training phase. And if I conduct an exam after 1 hour, that is what testing phase. Now what is a validation test is, during training I am asking you question whether you understood or not understood, and you are asking question on that. That becomes validation. So there is a training as well as testing, both happens. That is known as validation. Okay, so training, you are learning. Testing, which happens at the end. Validation is something during training itself. If I ask a question in between and I train you also at the same time, that it becomes a validation. So, sir, for example, there is a question. You have given a linear graph equation y is equals to mx plus c. How we can calculate values of m and c? Okay, m is a slope. We know that c is the y-intercept. Uh, we use machine learning algorithm, linear regression. We perform this calculation, and with that calculation, these constants are calculated. Okay, you can try mathematical approach also, or you can try linear regression approach also. A whole mathematics is behind. So this is out of scope, but you can drop a mail. I will share the documentation, or rather, I will tell you how it is calculated, how M and C is calculated. Okay, I'm moving ahead. Introduction to linear regression. Now, this will answer some part of your understanding. So, linear regression used to data to identify relationship between among variables, or you can say relationship between y and x. Okay, y and x. Okay, so user data to identify this relationship. We use the this kind of. Okay. A regression analysis describes the relationship between two or more variables. If two variables, we call this fine linear regression. But if you are going with the multiple variables, that is we call as a multilinear regression. Not necessary all the time we have linear regression like line, but we might have a non-linear equation, linear also. Okay. Example, income and educational level is an example of linear regression. Higher the education, higher the income. Demand for electricity and the weather. Home sales and interest rate. This everywhere we can try the linear regression. It does not mean it is always positive type directions. It might in negative directions also. Suppose for example, temperature rises in coastal area, humidity also increases. Okay, temperature decreases, humidity also decreases. So this is a relation directly in direction. But there are situations is that as speed increase, distance to cover decrease. Distance to cover decrease. So you can say relation between two variables. It not necessarily in a one direction. It can be in opposite direction also, and that's why before you perform linear regression on any data set, first of all we need to actually find out the correlation. Okay, covariance and then correlation we need to find out. Correlation help us to find out where there exists a relationship between these two variables or not, or repeat relation between x and y. If there exists a relation between x and y, then only we are supposed to apply linear regression algorithm on that data set. Okay, I think everyone clear. Can I get yes in the chat box? Okay, okay, thank you. Bhuneshwar. Now I'm coming to your question. This is a data set. Okay, why? This is a data set of egg or column or house number. Okay, so y and x is with us, and we have to calculate m and c. The model will give this y, m, and c linear regression. Okay, this is the vector data set. This is the price and this is the size. I'm plotting a graph. As soon as I plot a graph linear regression on that with okay, I am able to get this slope, and somewhere here it connects. I get a y intercept, and with the help of slope I get my m. Okay, I think this answers your question, or whole mathematics is also behind that. So as soon as I draw, this is another data set. I draw this actually where it connects on the y-axis. So when I'm saying this equation y is equals to beta 0 plus beta 1x, this x is, we know that y also we have, this is x and y is with us. Okay, and beta 0 beta 1 is our objective to calculate. That is the our model. So a linear regression line has equation form of y is equals to beta 0 plus beta 1x, or we mathematically we use a y is equals to m x plus c. So where x is the explanatory variable and y is a dependent variable. Okay, and we find a relationship between them, and the relationship provides the value of beta 0 and beta 1, or beta 0 is known as a bias coefficient and beta 1 is called as a scalar factor, or we call the slope of line also. Okay, in mathematically we call this is the y-intercept, and this is we call as the slope. So we must estimate the values of regression. We call as the coefficient of regression, beta 0, beta 1. And once we estimate this coefficient, we use a model to predict the responses. Then we take the new value of x, because we have some value of y, some value of c with us. These numbers are with us. We just have to place the value of what is the new x is coming. We get the new y. So at the end of this, we have certain equation with us. So this is how we calculate. So one, how to estimate a coefficient. One is called as ordinary least square method, another called as a gradient descent approach coefficients. So ordinary least square method is used in simple linear regression. Gradient descent approach is a multi-linear regression, right? So any doubt so far understanding this regression? Can I get a yes if you understood in the chat box? Okay, thank you, Sakshi, the first one to reply. Thank you, everyone. So this is a least square method. So there are many methods, not one. There are multiple methods which we can use. Least square method for ordinary least square method, and which we use for calculating the dependent and independent variable. What lines we can have, that lines we can see. This is y-intercept, and then we can calculate the slope, and we can have those values of x and y. So, so here beta 1 0 are the values. We will calculate only once, sir. Yes, we calculate only once. But as soon as your data set is increased, I think I suggest to recalculate those model, right? it might because up to certain decimal places. And if you are getting large error, we can use the some error calculation, or you can use a cost function. You can see on my slide I am discussing this particular option here also. The error is calculated with the least square method is used for calculating the error point between the line and the point. You can say this error is coming, this point should be coming on the line, but it is not coming. That is the error. I call it as the E, which is the error which is not explained by your linear regression. Okay, so that is calculated with the help of this particular formula. D is equals to summation, which goes from 1 to m d square. Okay, so distance between line and that linear line and the point. So that is, and we when we calculate summation is performed and square of that, what we get is a residual error, and that help us to get exact model. So actually the equation become like this: y is equals to mx plus c and plus e. So this e is calculated with the help of least square method, or you can it gives the error. Then other than that, we have another formula that is MSE, mean square error, which also help us to calculate the error. The error which cannot be explained by linear regression, which we used. So answering to your question, yes, we have to calculate once, but those are not static. It is changing. As your data set is increased, I suggest you to recalculate it. But yes, once model is created, but data scientists usually go on updating their models, which is required. Okay, because over the period of time, whatever the error is that, because as soon as data set is increased, sometimes the algorithm it changes over the time period, you may get error. Is to avoid that, we should recalculate as our data set has been increased. How to perform linear regression? Very simple. First, we have to calculate the mean and variance of it. Once you calculate the mean and variance, because this helps us to how much mean is there, how much mean of that particular value, variance, how it is varying from it, the original value which we supposed to have. Then we have to follow the covariance, how those two are grouped together. So that's why we have to calculate the variance. Then we should calculate the calculate the after variance covariance. We should calculate correlation between them. If there exists a correlation, then we should actually or estimate the coefficients, we should do it, and then the make predictions. Okay, and then we should calculate the error. Okay, and we can modify our model based on that feedback. So how we can perform linear regression using Python? We require a stats model and a scikit-learn. So these are the two topics we are going to learn today. This is for linear regression. Suppose you are performing a classification. We require to have the classification based on the accuracy. This is the model. We use a precision. We use a recall, whether our model is perfect or not. We use an error rate, which is calculated correct prediction divided by total prediction, and we use these formulas to calculate the accuracies. Okay, simply calculating the or deciding the model will not be helpful. We need to check how much error is there. Okay, because that only defines the quality of the model, and quality is very essential. Whenever we go for shopping, we check the quality of it. If you look at our elders when you're coming with us, they check the quality of the cloth, how it feels. Something feels a good a cloth, then only they buy. Okay, something rough cloth we don't buy, right? So the quality is very essential. So the models which we create, we need to check the quality of the model, which is checked with the help of accuracy, precision, recall, and error rate, or how much error is there. So expected and predicted, total 7 are correct, 10 are wrong, multiplied by 100, we get a 70% accuracy. This is a very simple example of that. And to calculate that, we have some confusion matrix, the predicted classes and actual classes. True positive, true negative, true positive main are classified as main. Main are classified, actually it is the women's are there. There is a actual. and we predicted as a main, so false positive is a false positive, and actually it is a main and we predicted as a woman, that is a false negative. Okay, and true negative, woman predicted as a woman, that is a true negative, right? So this worked very well. I heard there is another question. I heard of a overfitting, actually not a feeding, but dear student, it's not overfitting, it's overfitting. It's a fit when you're training a model. So minimize that, do not happen during a training. That's why we use a gradient descent algorithm. We check the model overfitting and over underfitting to be avoided. It's a fitting because I have these dots. These dots are there, right, on the graph. I will come to this. Uh, yes. Okay, I will take this example. If you, this is the line is drawing here. Okay. Now look at this. If this line goes like this is known as overfitting. If you get an equation which follows certain path, is known as overfitting. Okay. What is underfitting? This line is goes like this. It happens if you have a list amount of data set, then underfitting happens. Okay, overfitting happens, right? So you have to train your data set where appropriate type of things are required. How to check accuracy? We can use the root mean square error with the help of this formula, and we can work. So it's time to move to the coding part. Of my screen is visible. Okay, now it's time to we will though with a less time I'm ready with my all code. So first of all, I am going to import the Seaborn library. It's the alternative or Seaborn library is created on the matplotlib library, and because of that we can draw and everything graph. So I'm using it because I want to plot something, and I'm using Iris data set. So SNS is my object. You can see based on the Seaborn, and loading and load underscore data set is my function which loaded the Iris data set. So as soon as I execute and I'm writing it is head, head will display the first five records of it. You can check sepal length, sepal width, petal width, and species. As species is provided, you can say this is a classification data. So labels are provided. I can apply classification algorithm on that. Features, these all columns are the features of that. Okay. Setosa, these are the features. Okay. I can try tail also. I have shown yesterday. Satosawazar is Virginia. You can see the different records are here. So it depends on the what type of data set we have. Different classes will be there or levels will be there. Feature matrix. Okay, I'm just plotting that graph. So import Seaborn as SNS pair plot for all based on all the features and the species. Satosa, Varnaseer, and Virginia. I'm taking all the features on the left side and the right hand side, sorry, x-axis and y-axis, and I'm plotting the graph of it, right? So it's a pair plot which help us to get a complete visualization of that in a single click. I can see whole visualization of my whole data set. I can see whether there exists any type of regression or anything. These colors are shown. Satosa usually you can see in the first for sepal length. This is on the left hand side of it. Okay, in these two graph, this is sepal length and the petal length of it, right? So this is the something visualization help us to the interpretation of how my data is actually, right? You can have a few of it also, not compulsorily you require to have the plot all the graph, but this help us to understand how our data set is visualized, and we can do some interpretation from that. We are not able to see the cursor, still seeing the iris head. uh, Maybe I reshare it the screen. I will reshare my screen. Now I have used tried tail. This is iris tail, iris tail. I'm trying. Okay, so I am able to see this one. Okay, okay, I'm re-executing it. You can see tail. So last five records are shown. So I can there are 149 instances are there, 150 are there. Then I'm moving ahead. I can see this SNS pair plot, and this pair plot is able to visualize the all data set in a single screen. Moving ahead, uh, we can perform the use to extract the feature matrix and target array from a from which we can use for some pandas operations which we perform. Simply x underscore iris dot drop species. We are taking x axis one. We know that there are 150 records are there, and I'm taking the into the four of it. It gives the shape of it. This is going to display the shape. I'm taking y axis and I'm taking the species there, so the shape will be 150. Okay, now so I have provided some theory also which is required. Now I can try some scatter plot also on that, or linear regression on that. So I am importing the matplotlib library. I am importing the numpy library. These two libraries are required. And then I am writing RNG, a variable I am creating which stores the random numbers I am generating from the with the help of random function. So around 42 random numbers I am generating. So this is when we generate the random numbers. Okay, and x is equals to 10 into RNG dot random function and of the 50s. And then I'm writing for this is x m equation I'm writing, and I'm calculating y with the help of some other equation. Both uses the some randomness of it, right? And based on that, I am plotting a graph. You can see this graph. I'm executing it. This graph is plotted. So for linear regression, I can see there is those points are linearly visible. I can say that there exists a linear regression because I have performed EDA on this. Okay, but those are generative data set, but there exists a linear relationship between these all point. So I can vouch on that. There I can apply on linear regression on this selected data set. Okay, I'm just moving ahead. The linear regression model, choose a class of model. We have multiple models are there. I have to register from scalar linear underscore model import linear regression. I require this library also. Okay, this library consists of linear regression. It will it execute. I got green tea. I'm moving ahead. Model is equal to linear regression is the function. I'm writing a fit intercept. I'm able to click on this and writing a model. I can see the model is created, right? So this model is created, and we can model is created. Mathematical model is created. Okay. So you can see the when the model is instructed, the only action is to storing there is parameter values. So we are storing into certain variables. I call it as a model variable, and we can display whenever required to that. See, I'm just writing that x is equals to x. and I'm writing a new axis. For the purpose Kikitline, I'm using it 51 and fit the model of data. What are the model is created and now fitting the model dot fit, because model variable I have created. Now I created the linear regression. I have linear regression equation. Now I am applying a linear model on that. So this will fit the model. Okay, that model created now fitted the model. Now I am trying to print the its coefficient. This is the coefficient created. Coefficient is nothing but an m value. What is this m? M was our slope. Y is equals to mx plus c. The value of m is coming. I'm just printing a model dot coef underscore. That is my. I'm printing it. When I write the model intercept, I am get the c value. In case of mx plus c, this m value is printed with the help of this particular method. Okay, model dot coef and model dot intercept is printed. That is a value of c is printed of this. So I think the initially one of you asked me how this value was calculated. These are the value calculated with the help of this, and this will create a model. As soon as I write y is equals to 1.9777666 x plus rather not plus minus 0.9033107 is all the values are after this are known as my model. This mathematical equation which I got it after this is known as my model, that known as a linear regression model of it. Now I have a little time. I will move ahead and show you something. Now predict the unknown variable. I am just writing x fit, np line space. I am providing two values minus 1, 11, and then I write x fit and y fit, and then let's visualize the result by plotting the first raw data. And I'm plotting the graph linear regression line on this graph easily. Okay, so now after linear regression, let me show you some in a fast manner little bit because the time is ticking up. A supervised linear example, or you can it is classification. Okay, this is a simple model I'm using it. I am importing the sklearn, that is a very important, the sklearns library or sklearn also known as. This is a machine learning library by Python. I'm training testing split for that. I'm writing it. So import training test split of that class of that. Extend X test, Y train, Y test. I'm doing it. So I'm splitting X it is Y it is randomly on that. So I execute it. It's done. I'm writing the and now with the data range we can follow recipe to predict the labels. We can predict the label. Sklearn naive-based algorithm using is with the help of Gaussian NB. So I'm creating another model, and then model is equals to Gaussian NB. Then model fit back fitting X train and Y train. Now fitting the model and Y model is equals to model predict the X train. This will predict. This is done. Now finally we can enter the accuracy. This is the accuracy. 97% accuracy I'm getting. I'm applying it from scalar matrix, input the accuracy score, and Y test and Y model. Now this is the model which is given 97 accuracy. Of course, this is provided in the it's in the point. You have to multiply it by 10, and what you get is 97% accuracy. That is for supervised. Unsupervised also we can try. That is a PCA. It is a principal component analysis model which we can try on this model. And we are PCA 1, 2, and we are plotting all these different species on this scatter plot. This is known as scatter plot. And then we can try the Gaussian mixture. And now we are able to segregate all this. So if you look at the first graph and now the second graph after the classification, I am able to get three different clusters. I am plotted in the three different graphs to understand that. All data points were together, but I am able to segregate them, group them separately, and I'm able to place them separately. So one of the application of the cluster is that on YouTube we have a lot of videos are there. Those are placed together which are similar to in nature. So they use the clustering because there is no label provided many times, though they use the tags and all. But yes, the clustering algorithm is used on YouTube largely. So this is how it works. I have another algorithm. Program is also available. I have kept ready for you guys. Scalar dataset on loading the datasets, digit datasets. I have used it from the again, and now I can import matplotlib. My dataset is available. This is the handwritten dataset for numbers from 0 to 9, and these datasets. And then we apply. We can see this is the shape. This many records are available: 1797 and 64 columns. So now sample of 64 features are there, columns and features. And then applying, okay. Dimensionality reduction, we are reducing number of columns from 64 columns to, we are reducing number of columns. Then we are using a scatter plot. This is how it is plotted, right? Now those all numbers, there will be 9 categories are there. Then we have classification on that. And if you get accuracy, it provides 83% accuracy of it. And if I want to plot the confusion matrix of it, because we have 10 categories are there, 0 to 9, 10 categories on x-axis, 10 categories on y-axis, and this is how it is categorized. Okay, and we can check also. Okay, it's time to time is ticking up. So this is how the day 3 is ended. Now it's time to have some many questions from your end. So I'm looking at your chats. You can post any questions. But I will let me tell you, on day 1 we started with the numpys and basics of it, data structure, because we use all data structures. Then numpy. Then day 2 we discuss about the pandas, and then we discuss about the different types of libraries like matplotlib, Seaborn, and panda also was there. And today we discuss about what is the machine learning. In that we discuss about supervised, unsupervised, semi-supervised, and the reinforcement learning, different concepts, and discuss about the display, different type of trainings. And then we have seen few algorithms in all these three categories of the in all three different type of algorithms: regression, classification, and the clustering. So I'm waiting, looking at a chat. Any question, please post. I'm waiting for it. If you hope you understand, please provide your feedback properly. You just provide a thumbs or yes, yes, we understood. It will encourage us. Thank you, Bansari. Thank you so much, everyone. Any questions? Yes, yes. Today itself, I am going to share with my IT team, and my IT team is going to upload on it. Okay, don't worry about that. The presentations of day 1, day 2, day 3, and all Google Colab files will be shared with IT team, and they will upload on the website. So you just have to get it from the web link. Now, okay. Thank you, everyone.